Alright, this week we are going to get familiar with pulleys. Alright, pulleys are actually a simple machine that does find many applications, and it's a very small and very easy way to lift heavy objects up distances without applying a lot of force. So, a fixed pulley. In class today you should have hopefully at least gotten through this pulley in the lab and figured out its mechanical advantage, and hopefully you got one. A single fixed pulley has no mechanical advantage. It doesn't reduce the force needed by you to lift the object, but what it does do is change the direction. So what will end up happening is you're going to pull down on that end, and then the object is going to go up. Alright? Now, this will have all of the same things that we've seen before. So there's an FE, a DE, an FR, and a DR. Alright? So the distance it goes up is your DR. The weight of the object is your FR. And then the distance it goes down is your DE. And then if you think about a person sitting here pulling this, they're going to apply the FE. Okay? So, fixed pulley, simplest of all pulleys. It's actually not a useful machine because it doesn't change the amount of force you have to apply. The force you apply is equal to the force of the object, the weight of the object. Now, the simplest helpful pulley is something called a free pulley. Alright? What ends up happening with free pulleys is you're going to actually have to pull up on the pulley. Okay? So this is going to move up. Then that's also going to cause the weight hanging from the pulley to move up. So here's your DE. You're going to apply some sort of effort force. And then how far it moves up is your DR. And you still have a resistance force related to the weight of the object. Alright? So for a single free pulley, mechanical advantage is 2. What that means is that your FR is 2 times your FE. Alright, so if you're applying 50 newtons, you can lift something that's 100 newtons. Alright, or if the object is 500 newtons, you have to apply 250 newtons to lift it. Okay? So, mechanical advantage, there's a trick with pulleys to figure out your mechanical advantage. And that's the point of the lab we're doing in class. You need to figure out the pattern. If you don't get the pattern, I'll tell you what it is tomorrow, but it doesn't help you with your lab. But something that will help with your lab is there is more than one way to figure out mechanical advantage. So far, we have figured it out this way. Alright, mechanical advantage equals your resistance force divided by your effort force. But there's actually a second way you can write it. And it comes from this equation. Because this equation has both FR and FE in it. So let's rearrange the equation to make it look like this. Our mechanical advantage equation on one side. Alright, so we want FR on the top, which means we need to move FE to that side. So we're going to divide by FE, divide by FE, those cancel out, and you end up having DE equals FR DR divided by FE. So we're almost there. You can see mechanical advantage, but we still need to move the DR. So we're going to divide by DR on both sides so that those cancels out. And then you're left with DE over DR equals FR over FE. We know that FR over FE is mechanical advantage. So what we can do is we can replace that with MA. And that tells us that mechanical advantage is also equal to DE, your effort distance, divided by your resistance distance. Okay, so there's 2 ways to calculate mechanical advantage. And that's the one you already learned, and then this new one that we rearranged for. All right. So applying this to a sample problem, so if the mechanical advantage of a pulley is 3, All right, so we know MA equals 3, and you pull down 9 meters, so that means your DE is 9 meters. And how far will the pulley move an object up? So our dr is our question mark. All right. The equation you're going to use is MA is equal to DE divided by dr, and we need to solve for dr. So that means in order to get dr out of the denominator of a fraction, we need to multiply both sides by dr. All right. Which will give us dr times MA equals DE. Now we still aren't solving for dr yet, so we still need to get rid of that MA, so we're going to divide by MA. And that gives us dr equals DE divided by MA. All right. So using that, we're going to plug in our numbers. So let's make a little bit more room so we can do this. So we're going to take our information from up above. We know that DE was 9 meters. Our mechanical advantage was 3. And that's going to give us 3 meters is our dr. Okay? Sorry about that. So looking back at this together, just keep in mind that MA equals DE divided by dr, and you can rearrange that to solve for any of the pieces. So like DE is equal to your mechanical advantage times your dr, or dr is equal to DE divided by mechanical advantage. Those are some things you'll want to get familiar with, but we'll deal with this some more on other days and get into some more applications of this the next couple of days. Right now, we're done with this video, so make sure you do the assignment that is titled Pulley Video 1 by 7:20 a.m. tomorrow morning, and I'll see you in class.